So our topic here is actually how to actually work with descriptive statistics. Okay, so as we know, statistics is a big part of Excel actually, and of course, it's also a big part of our everyday life. In fact, a lot of us field are starting to use statistics, especially in the field of data science and accounting, and of course, management. Okay, let's look. When you talk about statistics, there are two branches of statistics. One is called as the descriptive statistic, while another is called as the inferential statistic. So when you work with, when you talk about descriptive statistic, normally you work with the population. Hey, what is population? You might ask me. Okay, in statistic, population means the whole set of data. You already have the whole set of data with you. But when you talk about inferential statistic, that means you don't work with the whole population. Instead of the whole population, you work with the subsection of the population. Reason is maybe because the volume is too large. And it's not practical to work with the whole population. So what you do is you just simply take a subsection of the population and you do kind of estimation. So this is what we call as inferential statistic. So we are going to focus on the first one, that is the descriptive statistic. Okay, if you look in Excel, if you go to the formula step, in fact, after 2016, that you notice that a lot of new function has been added to the libraries itself, especially for statistics. If you look here, you can see that there is actually a statistic library over here. Notice the word math and trigonometrics. Next to it is actually the more functions, and you can drop down and can see the word statistical. So you can see the list of statistic function that is available for your disposal in Excel. I think most of them, some of it you have actually used, for example, like average. This is actually a very popular function. And of course, the count and counter, count blank, count if is also part of the function that is available in the statistical libraries. Okay. So since I mentioned just now that we are going to work with the descriptive statistic, where you have the population of data. That means the whole data is at your disposal. Okay. This is very simple example of the data I'm working with. Okay. And the first thing that you notice here is that when you talk about descriptive statistic, is that we are trying to get a single value that can actually represent our whole data set. We are trying to get a single number that can represent our whole data set. That means the whole data points here, for example. Okay, all right. Okay, the first function that I'm going to share with you is the mean. That is basically the average of our data set. So the function that we are going to use is average. Yeah? So we don't have the function name mean, but we use average. Okay, average is actually the equivalent of the mean function in statistics, and I'm going to highlight our data here. So in this set of data, this is my mean actually, the value 90. Okay. All right. Okay. Okay, good. Okay, but is it the best option that we have? Yes, because we will be able to actually display a single numbers that reflect our whole data set. But we will have some problems over here is when I'm going to replace this 120 with 980. Okay, you can see that this is something a little bit off away from the pattern of our data here. Very much differentiating. And here also I'm going to put some value here, another another value maybe. I'm going to add up another value. I'm going to put there 1. Okay, so this can be considered as an outlier. Okay, what is actually an outlier? Outlier, a value that is a minority value that is different from the majority set of the values. Okay, kalau kita lihat dekat sini, kita nyatakan dua elemen atau dua nilai ini sebagai nilai yang di luar kelaziman. Perhatikan, jadi kita nampak kedua data yang saya tambahkan tadi adalah nilai yang berada dalam lingkung ataupun lingkungan yang luar daripada kelaziman data yang ada kat sini. Tapi adakah dia akan beri kesan kepada kita punya mean? Jawapan dia ya. Kita perhatikan dekat sini. Saya akan buat semula average tadi dan saya highlightkan seluruh data ini. Kita lihat nilai dia jauh berbeza dengan nilai purata asal tadi. That we notice now that initially the value was about 90, but now it's 160. You can see that the value that we get now is far away from the mean value that we get just now. Just because there are two new values that is very off away from the pattern of data that we have. We call this as an outlier. Okay, so when we have outliers, sometimes the mean at times fail to deliver a fair value of the data. Dengan kata lain, nilai tersebut mungkin ada waktunya tidak dapat memberi gambaran yang sebenar terhadap kumpulan data kita. Maknanya kita boleh kata dia distort atau terpesong. Walaupun dia bagi jawapan, tapi mungkin dia tidak dapat beri gambaran yang sebaiknya. Jadi macam mana kita nak handle ataupun kita nak selesaikan benda ni ialah satu lagi pilihan yang kita ada ialah kita boleh gunakan elemen median. Sebenarnya saya tertinggal satu benda tadi. Kita panggil benda-benda yang kita tengah buat ni measure of central tendency. Jadi kita gunakan 3 function utama dekat sini. Yang pertama ialah mean, yang kedua ialah median, yang ketiga ialah mode. Okey, ketiga-tiga ini adalah kaedah mengukur measure of central tendency. Maknanya kita nak cari nilai pertengahan dia yang berupaya untuk mewakili keseluruhan dataset. Okey, jadi kita ada pilihan menggunakan median. Apakah kelebihan median? Median akan ambil nilai pada kedudukan yang paling tengah. Jadi sedikit sebanyak dia akan mengelakkan daripada kesan outlier ini. Sebab kita tak ambil keseluruhan, sebaliknya kita ambil nilai pertengahan. Jadi nilai pertengahan ni kalau kita perhatikan dekat sini, kita perhatikan jumlah nombor yang kita ada dekat sini. Adakah perhatikan dari segi nombor ni, kita tengok kalau kita perhatikan dekat sini, kita tengok jumlah bilangan nombor ni adakah dia even atau odd, genap atau ganjil. Okey, genap. Jadi kalau genap, apa yang kita kena buat ialah kita kena pastikan kita akan ambil 2 nombor di pertengahan. Jadi ini akan menjadikan bahagian sebelah kiri dia ada bilangan nombor yang sama dengan sebelah kanan dia. Okey. Dan kemudian kita akan jumlahkan keduanya dan bahagi dengan 2. Itu yang biasa kita buat. Tapi akan berbeza sedikit jika nombor dia adalah ganjil. Kalau nombor dia ganjil atau dipanggil odd numbers, maka kita akan ambil nilai, tak perlu ambil 2 nombor, kita ambil single number dan kita pastikan di sebelah kanan dan kiri dia ada bilangan nilai yang sama lah. Jadi contohnya dekat sini, saya ambil di sebelah kiri dia ada 5 dan di sebelah kanan dia ada 5. Jadi saya ambil nombor pertengahan ini sebagai nilai median. Tetapi kiranya dia adalah genap, maka saya akan ambil 2 nombor yang ada di pertengahan itu dan pastikan selain daripada 2 nombor tu, sebelah kiri dan kanan dia ada bilangan yang sama. Apa yang kita akan buat ialah kita akan jumlahkan 2 nombor ni dan bahagi dengan 2. untuk mendapatkan nilai median. Jadi kita akan cari pula macam mana cara nak cari median. Kita gunakan function nama dia median. Dan seterusnya hanya pilih the set of data kat sini. Jadi kita nampak kita ada isu yang outlier tadi, iaitu nombor yang terlalu kecil dan nombor yang terlalu besar. Dan tapi kesan dia tidak begitu menghambat kepada data kita, sebab dia ialah dia tak kacau, yang dia tak main dengan benda ni. Dia cuma ambil nilai tengah. Jadi dia akan dapat bagi kita a more fairer value berbanding kalau kita gunakan mean. Jadi kita dapat lihat kita juga boleh gunakan median untuk mencari the measure of central tendency tadi ya. Okey. Kemudian kita ada mode. Mode adalah function yang boleh tengok keberangkalian atau highest, bukan keberangkalian, maknanya berapa kerap ulangan dia ataupun the highest frequency. Jadi contohnya kalau kita nak gunakan, nak tengok berapa nombor yang lebih daripada sekali kat sini, kita boleh gunakan arahan nama dia mode. Dan kita akan dapat nilai yang kerap diulang ialah 99. Jadi 3 elemen ini kita sering kali gunakan untuk mencari the measure of central tendency. Jadi kita nak cari satu angka yang dapat mewakili kelompok data kita. Jadi perhatikan dekat sini kita ada kelompok set yang kedua ni. Kita akan cuba cari mean dia. Kita gunakan arahan average. Dan seterusnya kita highlightkan data kita. There you are. Kita dapat nilai mean dia adalah 170. Median. Okay, kita dapat ini nilai median dia. Dan mode dia. So ini antara 3 function yang kerap digunakan bila kita nak cari tendensi kita tu. So kita ada option untuk main dengan median, mean dan juga mode. Okay. Alright, kita ada mean, median dan mode. Kita boleh buat benda yang sama dekat sini. So kita nak cari mean dia. Okay. So kita gunakan arahan mean sama dengan mean. Kemudian kita gunakan arahan average. Okay, average ya, average. Alright. Okay. Ini nilai mean kita, ini nilai median. Dan seterusnya ini nilai mode kita. Okey. Kalaulah kita dapat data yang sebegini, kita nampak sama je semua nilai dia. Maknanya mean, median, mode sama. Maknanya kita punya skewness ataupun kita punya distribution data kita panggil dia symmetric. Okay, symmetric maknanya seimbang. Okay. Begitu juga dengan data di bawah ni, saya akan cuba gunakan arahan yang kita belajar tadi. Okey. Kita akan buat benda yang serupa. Okey. Kemudian enter. Okey. So kita tahu kan, kita kadang-kadang bila kita boleh buat kesilapan . Bila kita buat silap, dia akan bagi tahu kita kesilapan kita tu . Name tu bila you dapat itu error punya message tu. Okay, ini ialah median kita. And now we are going to look for the mode. Okay, right. Okay. So this is the measure of central tendency for our data set here. You can see over here. Okay. All right. Apart from using a measure of central tendency, we also have another way of working with descriptive statistics. Okay, that is basically the measure of variability or the data dispersion. Okay, All right. Among the things yang we can actually work over here is actually looking at the percentile. Okay. So if you look here in the screen over here, you can see that when we work with a group of data, we always have percentile, Q1, Q2, and Q3. And normally you have 5 different indicators here. The starting one, the Q1, Q2, Q3, and Q4. So Q2 is basically our median. That is our 50th percentile. So in Excel, you can actually get the percentile easily. Okay, so just have a look over here. What you can see over here is actually, this is the range of data that I'm having here. Okay, I'm going to actually get the initial value. Okay, all right. So I can actually use the percentile function. Look here, I can use the percentile function. Okay, I'm going to click percentile. Then I'm going to actually, the data range, I'm going to highlight the data range. Then put a comma, and I just put the value 0. Actually, this will be our initial value. That is 36, correct? And our 25th percentile value will be Q1. I'm going to use, so I'm just going to, hang on, just give me a minute. I'm going to increase the zoom of our here so that you can see. All right. Okay, I'm going to put an equal sign, percentile, and then highlight the range of data. Then put a comma. Then I put the 0.25. Okay, so that is basically percentile for 25th percentile. That is our 25th percent. The value will be 89.75. Okay, then this Q2 will be our median value. That means the value is at the center. Okay, so we are going to use the percentile command here. So range of our data, then point, comma, 0.5 or 0.5. So this is our median. You can see from the exercise before, our median is 99. Okay, so this is actually the 50th percentile. Okay, now we are going to go to the third quartile. That will be 75%. So we are going to use the percentile command here. Highlight the range of data, then comma 0.75. So the value will normally be 0 to 1. Okay, so this will be our 75th percentile. And the Q4 will be 100%. Okay, so it will be percentile. Okay, range of our data here, then comma 1. Okay, so this will basically show our Q1 percentile, Q2 percentile, Q3 percentile. Okay, so you'll get this is another way of getting the value, a more fairer value, especially when you have outliers. Okay, which can have can distort the fair amount of value that represent your data set. Okay, and another way of getting a fairer value of your data set, you can use the interquartile range. Okay, interquartile range is where you take the third percentile and minus the first percentile. So if you look here, I can show you over here. So if you look here, the interquartile range is actually, we take the upper half one. You can see from the upper half, we take the Q3 and we minus with Q1. So we will get a median, we can get a value that gives us a much fairer representation of our data when there is an element of outliers. Okay, right. So that means when you have outliers, it will actually not include this and all the other part over here. So you will be able to get a more fairer value that represents your data set. So if I want to get the interquartile range, what I do is I take the Q3, that is this, and I minus Q1. So the value I notice here is the IRQ value, the interrange quartile value. That is supposed to be a fairer value that represents your whole data set. Okay, apart from that, you can see there are other things that you can notice over here. For example, when you talk about statistic, you can see the element of variance, for example. Okay, this is actually the statistical function over here. You know, this might look complicated, but with Excel, you can do it easily. If you look here, what is actually the variance? As you can see over here, this is basically that defines the data points. How far is the data point for the mean value? So you can see over here, this is the data we have. Then we always have our mean value. So we know our mean value is, for example, for the first data set here. I'm just going to zoom in for you. All right. So I'm going to put an average value here. That is the mean. Okay. So we are going to highlight this and we're going to press enter. This is the mean value. And we want to know how far the other data is from our mean value. So what we can do is we can actually use the variance. Okay. So we can use variance. I'm going to use .p because I have the population data here. So I'm not working with sample. Okay. I'm using population data and I'm going to highlight this data here. So this will tell me my data set, what is the value of the variance that reflects how far is our data point spread away from our mean value. So this is the element of variance. Okay, another popular term when you work with statistics is the standard deviation. If you look here, standard deviation is basically square root of your variance value. Okay, square root of your variance value. Okay, so if you look here, so of course we always have the mean value. Okay, mean value is our indicator, the center of our data. Okay, this is the data. So we want to actually, get this is the mean value. Okay, and then we want to get the standard deviation value. So as you know, when we talk about standard deviation, the bigger the value is actually the square root of the variance. When you have a lower value of standard deviation, that means it's nearer to your mean value. Okay, the central value of your data set. But you have a higher standard deviation that is further away from the mean value. So you can actually measure the standard deviation. If you look here, the graphic, I'm actually dragging it up, is basically that reflects and shows the standard deviation formulas. So I'm going to use this in our Excel, equal sign standard deviation. So you can see over here, we have standard deviation population, P, and I'm going to highlight the value. So if you see here, this is our standard deviation value. Obviously, you can actually decrease the, so you know that it's about, this is the value. So why not we compare that with our second?
Very good answer.
Why not we compare that with our second data set here? Average.
Can I ask you a question? And then we're going to
highlight this data over here. So this is going to be our mean value for our second data set. And we want to actually measure the standard deviation value. Okay. Okay, let me look. So our standard deviation for the second one is STD, will be population also. And I'm going to highlight this. Hang on. This is our second data set, and you can see that, Just, I know we are running out of time. Just give me a minute, please. All right, I'm going to highlight this. Okay. So this is basically a simple way of actually measuring our data. So that you can notice over here that for our first one, we have a lower standard deviation, a higher standard deviation compared to the second one. That means it's away from the mean value compared to the second one, which is only about 19. Okay, so I think this will actually show us way of actually getting a story behind our data. That's the most important thing. We talk about insight, gainful insight to make informed decision. This is the way that we try to get what is actually behind our data. So the method that just now I was actually working with is all the function. But do you know that in Excel, you have a tool that is called a statistical analytical tool, which is simply an add-on, and people normally don't use that. In fact, it can actually help you to work with statistics, either descriptive statistics or even inferential statistics, apart from the option of using other statistical tools, such as SPSS. Okay, how do we install that? Okay, if you look here in your file tab here, you notice there is actually, you can actually go to the options and you can see the word add-ins. And you notice here by default, it's not installed or it's not activated. Okay, what you need to do is you look at the manage drop down here and you click the go button and just checkbox. You can see the analysis toolpath checkbox, the analysis toolpath VBA, and then just click OK. Now you will have the tool to actually help you in your statistical analysis. So where is it located? Let's see here. If you go to your data tab here, you now notice there's actually a group called as analysis here and a data analysis. This basically helps you to work with work with statistical tools that you want to work with. Okay, I'm going to show you over here. Look here, I have a data over here. If you look,
hi.
For example, we have amount of money deposited in a bank. For example, I'm going to try to analyze this data using the analysis tool. Just give me a minute. So sorry. I know I'm actually off the over time already, but just give me a minute, please. Okay, now I'm going
it's a very interesting one.
Okay, so what you need to do is just go to your data tab here, click the data analysis tool, and you'll notice that there will be a dialog box, okay, that allows you to do all this data analysis work. Okay, for example, you can work with correlation, covariance, ANOVA, okay, and then obviously you can do regression and all that. But as we learned, we are working about descriptive statistics. Look here, I have the option descriptive statistics. And I'm going to just click OK. I get a dialog box where it will tell me to select my input range. Okay, I'm going to actually select my data over here. Then I'm going to actually control and go down. Then I'm going to actually label is not in the first row, so I just it's a new workbook. And then I'm going to actually I want to display the summary statistic, and of course the confidential level and I just check it all and click OK. And what will happen is that it will give you all the details about the descriptive statistic for you. And now you look over here. This is the descriptive statistic I get in a single click. This is the mean value, the standard error value, the median, the mean, the variance, the standard deviation, and also the range and the other elements over here. So you can do it very fast. And I think this will open up your interest to learn more about statistics with Excel. So I think before I pass the baton to my friend, are you okay? Can you give me a few more minutes, brother? Ken?
We need to
you are running out of
be on time, lah.
Okay, no mind. Maybe I can pass the baton.
Sorry
to
interrupt you. I think we need to pass to Ken.
The baton to you, Ken, now.
Yeah, thank you.